Hello everyone, this is Kevin from PCI Geomatics. Welcome to our webinar entitled UAV Processing and Information Extraction with Geomatica. It's 8 o'clock here in Ottawa, Canada. We're really happy to have you with us. We're going to wait maybe another 30 seconds, give you a couple of minutes or just a little bit of time to settle in, and we'll get started. Okay, might as well get started. So welcome once again to our webinar entitled UAV Processing and Information Extraction with Geomatica. So our presenters today are myself on the left, Kevin Jones, Director of Marketing, and joining me is Jason Flatt, who is one of our technical solution specialists. You'll be hearing a lot more from Jason a little bit later on when we go through some live demonstrations. So all the lines are muted, which allows you to talk. If you're in a room with other people, you can discuss what you're looking at. You can keep working. You're not going to disrupt the session. We really encourage you to type questions throughout the session. So if you see something and you have a question about it, don't wait until the end. You can type it in right away. Myself or Jason will try to answer them as we see them come in, and we'll also save some up for the Q&A session at the end. We're recording this. We always record all our webinars. We'll be sending around a link to the recording, normally within 24 hours, sometimes a little bit faster than that. We have a series of webinars planned. This is the second in our current series that we're running since we started the new year. So we did an Object Analyst Automation webinar last week on January 28th. We're doing the UAV processing this week. Next week, we're doing Sentinel-1 TOPS, which is a synthetic aperture radar topic. And then we also have an upcoming webinar on processing RadarSat data and RadarSat Constellation Mission data, RCM data, which is data that's being collected by 3 new satellites that have been launched in mid-2019 that are Canadian. So today's webinar is as follows. So we're planning to give you an end-to-end demonstration of the UAV processing workflow within Geomatica. We hope that you come away from this session understanding that we have unique live editing tools that are very powerful. We also have the ability to extract digital surface models at the same resolution as the input imagery. So one-to-one resolution between the DSM and the ortho images as per the collection resolution on board your UAV, which is really advantageous for many different reasons. Information extraction. So while some of you might be familiar with other software packages for stitching or processing your UAV imagery, we have, of course, a rich set of tools that we've been developing over a number of years, and including information extraction or object-based image analysis, which we'll be showcasing as part of this webinar. And to that end, we'll be showing you how to extract volumes using the derived elevation that we extracted from the stereo overlap in the UAV, in a particular UAV data set that we processed, which is openly available, and we'll be giving you links on how to get it and how to process it yourself. So just a few quick words about PCI. So we create and deliver geoimaging software products, platforms, and solutions for a global customer set. So we've been around since 1982. We are in our 38th year of business, and we're just really leveraging a lot of intellectual property that's been built up over the years to handle satellite imagery, both optical and radar, UAV imagery, aerial imagery, and everything that needs to be done to correctly position those images on the ground, to correctly normalize those images so that multi-temporal analysis can occur, and just extracting information automatically or image processing in general. So we have a lot of capability. And that capability is expressed in a number of different software packages that we have available, which is really meant to scale with your operations. So we have been developing Geomatica, which is a desktop image processing software tool, for a number of years. And going back within the last 10 years, what we did is we deconstructed the entire desktop package so that we could build it back up into individual modules. We call that today, one expression of that reconstructed module is our large volume production system known as GXL, or Geoimaging Accelerator. And what makes all that possible is basically an API that sits under the hood of all of our algorithms. And that's a Python API. So you can take individual algorithms and you can string them together. And if you want to connect them to a data source or other processing after you leverage PCI technology, then you can totally do that. So it's extensible, it's scalable, and it's really more of a platform than a standalone tool is the way we like to think of our tool set. So I guess what's new is that we have released Geomatica Banff. So this is our latest and greatest release. It was released on November 26th in 2019. So just about, I guess about 3 months ago. And let's take a look at what's new as it relates to UAV. Before we do that, we're going to launch the first poll. So I'm going to go ahead and do that. So we're just wondering, in terms of UAV processing today, what are you currently using? So we're going to be showing you Geomatica today, which is, for those of you who know us, it's a photogrammetric workflow that has primarily been developed for satellite and aerial imagery. And we've been offering the possibility to process UAV imagery for some time. However, we've really been investing in this area more recently. So these are maybe some of the people that have been offering technology for longer than we have, specifically for the UAV market. And we're just curious to see what you're using. And if you, I notice a lot of you are selecting other. If you did select other, we'd love to hear about what it is that you're using. So you could just type it in the questions panel and let us know what that is. We'll have a way to know how you answered this specific question. So I'm going to close it down in 3 seconds. So 3, 2, 1. Thank you so much. And I'll just share the results there with you so you can see Pix4D, Agisoft, Trimble, and Drone Deploy kind of in logical order. But I noticed a lot of you are using something else. So looking forward to reading all about that in the comments once we're done. So back to the slides. So I'm going to go through the highlights of the release as it relates to UAV. So we have the ability to perform end-to-end processing for UAV data sets because of some new technology that's been added. We've added new type point collection methods. We have a new point refinement method for both ground control points and type points. And we also have integration. So in general, the integration of this functionality within our tools specifically for UAV. Now it makes use of specific technology that's been developed previously that's absolutely 100% relevant for UAV image processing. So the one key thing that is critical is being able to extract DSMs at 1-to-1 resolution and being able to reconstruct the surface models using the multiple look angles or multi-view reconstruction. We also have the ability to generate ortho images directly from the DSMs. And we have some really intuitive and easy to use editing tools for editing the DEM with the goal of improving the quality of the ortho imagery and then the resulting mosaic. And we also have some post-editing tools, things like Smart Geofill, and Jason will be showing you a little bit of that as part of today's webinar. So in terms of supported platform, really we don't really have any limitations, I guess, in terms of what platforms we can support. These are just some examples of the specific UAVs on the left, what cameras they're flying with, and what channels are available. These are the most common, but you know, within our system, we can basically, as long as we know the focal length and we know the chip size, then you can get started with the UAV project. So these are just some of the things that are included in the UAV package. So we don't have a specific UAV package that we sell separately. We basically position the Geomatica for aerial image processing. So you could actually process full frame metric cameras or UAV. So if you have ultracam data, or if you have DMC data or ADS RC30 data, any kind of full frame metric camera, you can actually use the same software to process both the UAV and the aerial data. But it breaks down as follows. We allow you to extract DSMs. We can filter those automatically to a DTM. And then you have the option to generate a DTM ortho image or a DSM ortho image. And then you can take all of those ortho images and create a seamless mosaic. These are some of the improvements that I was referring to earlier. So we have our feature-based matching. So this is based on the SIFT algorithm, which really does a good job at collecting tens of thousands of points very, very quickly. We've implemented this to be extremely efficient in our software. And what this will do is it will basically allow you to fix the orientations and get your project started. This is what the workflow looks like. So the UAV data ingest. So basically the way the data is typically collected is in the form of a JPEG file. And in that JPEG file, because there's navigational software that's on board the drone, there's a series of latitude and longitude coordinates that are stored in each image and in the EXIF tags. So we basically harvest those coordinates through the EXIF reading, and then we get the rough orientation going. Then we can collect points using the feature-based matching. Then we can refine those points to converge on a model that allows you to basically generate the high quality products, extract the DSMs, generate the DSM ortho or the DTM ortho, your choice, and then generate the mosaic. So just highlighting a couple of things. So typically what you would do is you would ingest the data, do the point collection, then you'd run the point refinement, which really allows you to remove blunders. So this could be automated or it can be manual. It's really up to you. The DSM extraction, you can use the DM editing tools to repair artifacts and see what that's going to look like on the ortho. So this is a really nice tool, so you don't have to generate the orthos and then fix the DM and regenerate the orthos. You can do it interactively. And then the mosaicing step is also unique in our software in the sense that you can improve the color balancing automatically, but also using very, very accurate and localized features. So we have dodging points that are either edge dodging points along seam lines or floating dodging points. So lots of cool and innovative tools that really aren't out there in the marketplace besides what PCI has developed. So I've mentioned this already, but basically we have some other things. We have our feature-based matching, which I talked about. We have another algorithm, which is going to be soon available in a point release. So we released in November 2019, and we have a point release coming up probably within the next few weeks, within the next, I would say 6 weeks or so. And that point release is going to have the tie image functionality, which is a different point collection algorithm, which is quite good as well to converge on a model much more rapidly. And some other things that we have is DSM merge within Ortho Engine. So these are some new techniques that are in the software right now. They've been released with these capabilities. However, they're not perfectly all integrated in the current release, and the point release is going to address some of this integration. So that's what this slide's about. terms of camera calibration, so right now, as I mentioned, in the current release, we have primarily the quality of the result will depend on the quality of the camera calibration. So it's very, very important that camera calibration is performed, especially for UAV cameras. So the key difference between metric, cameras such as UltraCam or RCD30 is that those are calibrated cameras. They typically get sent to the manufacturer. We get a camera calibration report, and we can enter these camera calibration parameters to model the lens distortion, which is going to have a big impact on the quality of all the results. With UAV images, camera calibration doesn't really happen that way. It happens more in terms of camera self-calibration. So using the actual points that are collected across the block, we can model the lens distortions inside the imagery. So at the current moment, you should take care to bring external camera calibration from another source. However, we are working on technology to make that available in the coming point release. We understand that the market expects PCI to provide camera self-calibration, and we are working diligently to provide that in the next point release. So next slide. So it can be external at the moment, but we are working towards providing our own. This is just an example of a camera calibration report that's been provided from phase 1. So we use a standard camera calibration file format, which is a USGS format. You can see it there. And so you can enter all of these parameters in manually, or you can import a .cam file. It's up to you. So just in terms of what success we expect you will be getting with our software at the moment. So we developed this table to give you a sense of with the current release, if you look at those two green boxes in the top left, basically we need to know the external orientation. So we will extract that from the EXIF tags. So no problem for PCI, we can extract that from the EXIF tags. And then we can use an external camera calibration report. So the key difference between nominal and solved is nominal would be EXIF tag level external orientation. So we can absolutely use that and converge on a model. But if you have more accurate external orientation, like a more calibrated set of exterior orientation from some initial aero triangulation that's been performed outside PCI, of course, that's going to be quite good as well. So some of the problem areas right now in terms of the yellow boxes, which we hope to turn to green with the next point release, is basically deriving the internal orientation, which is another way of saying the camera calibration. So once we have that camera calibration, in either case, whether we have the solved EO or the nominal EO, you'll be able to work with many more projects than you can currently work with our software. This is just a panel that shows the feature-based matching capability. So it's a new point collection that's been added. Again, it uses SIFT under the hood, and it really is able to fix a lot of the orientations. You can see in this slide that we have some slides which, some images on the left using the nominal exterior orientation, which don't have the proper kappa coefficients because we just don't know which way the images were collected, or we're unable to resolve that using the nominal external orientation. But by collecting a series of points, we can fix the orientation and the scale of some of those images, and then from there derive a more rich, dense set of points. Point refinement is basically a way to remove blunders and converge on a model. So what you see is basically a panel that allows you as the user to set a target RMS for your project. So if you want to get to a 2-pixel RMS, then what you can do is you can basically set that, and what the software will do is it will automatically remove points on an iterative basis, compute the block bundle, and then work its way towards converging to a final solution as per your requirements. UAV Multiview DSM Extraction. So we use a technique. So as I mentioned in the beginning, we've developed a lot of technology as it relates to aerial imagery over the last few years. And one of the key technologies that was developed for metric full frame cameras is semi-global matching. And that was really to allow us to extract high quality elevation models from high resolution imagery. So the SGM capability is available, and it will allow you to really extract some high quality elevation models. And we also have the ability to merge those DSMs. So we basically pair up all the different stereo images, extract the DSMs, and then we merge them together and derive the best elevation value for each pixel using all of the multiple pairs over that location. That's what multi-view DSM generation means. These are just some examples to give you an idea. So we have a 6.5 centimeter UAV data set collected over a quarry or a mining location. And you can see just the level of detail is quite good, very smooth, and it's at the same resolution. So the DSM and the ortho imagery or the ortho mosaic is at 6.5 centimeters. So this is a great source of data. Here's an example from a 1 centimeter data set. So you can see the one-to-one resolution. So if I zoom in here to this particular location, you can see that we can even see the trunk of this particular vehicle is opened up, and that's reflected on the DSM. We can see the elevation value is a little bit higher. So quite a lot of detail available, and just a great way to extract information, elevation information from UAV data sets. We also have UAV mosaicing technology. So again, leveraging the aerial mosaicing. So we have advanced color balancing. We have a bundle method, basically, which allows us to globally adjust the colors, but also locally address specific areas. So it can be completely automated, or you can basically go into specific locations and adjust specific areas. We also have the ability to stitch, basically, or select the most nadir regions of different images to get the best viewing geometry and get the most nadir looking and aesthetically pleasing ortho image. Here just, yeah, okay, so one-to-one DSMs. Sorry, let's keep going, yeah. So we're just gonna talk about DSMs. So if you wanna get those high quality DSMs, these are some of the conditions. So it's ideal to have good camera calibration or to be able to derive good camera calibration. It's also desirable to use survey GCP points with height. So if you have surveyed GCPs on stable surfaces, and you can add those into your project, which will help with calibrating the heights on your UAV extracted DSMs. Just in terms of getting a nice smooth result, if you're flying your UAV data set, you want to capture as high an overlap, forward overlap as possible, and as high a side lap as possible as well. So we recommend 80-60 as a minimum. And you really need to have a good distribution. So as you're calculating your model, you need to visually, and we provide you the tools to do this, you need to visually have a good distribution of tie points and GCPs across your whole block and a low RMS value. Just some more examples here. So one-to-one DSM from a particular data set that we processed. Okay, well, at this point, I'm going to pass over to Jason, who's going to give you a live demo on how to achieve some of this using Geomatica. Over to you, Jason.
Thanks, Kevin. Hello, everyone. Just give me a quick sec to get out of the PowerPoint. Hello again. So thank you, Kevin, for the amazing introduction, and good morning, everyone from Ottawa. So as Kevin quickly mentioned, we are going to be working with some data that's freely available from the SenseFly website. So you can easily download it after this webinar and process it yourself. So as Kevin talked about, we are going to ingest a subset of, I'm going to go through the whole UAV workflow, and that's going to include ingesting the imagery, UAV imagery, improving its initial triangulation with tie points, extracting an elevation model and using said elevation model to produce true orthos or DSM ortho imagery, and then mosaicing it through the whole Ortho Engine Geomatica workflow. So I'm going to utilize a subset process. So we're going to go through this whole workflow. So what we're going to see is we have a number of JPEG images from the UAV imagery. I'm just going to open up Ortho Engine, and we're going to go through the process together. So where we're going to start, we see the Ortho Engine window. We're going to go to File, New to create a new Ortho Engine project, and we're just going to create a name. We're going to go to Browse. I'm going to go to the file pathway. We're going to call this Webinar Ingest. Great. We're going to give it a new name. We're going to call this Webinar. And because we're working with aerial or UAV imagery, we're going to select the aerial photography math method. And for the camera type, since it's UAV, we're going to choose digital. And because we're going to improve the initial triangulation from the EXIF tags that are red, we're going to collect tie points. So we're going to leave EO at default compute from GCPs and tie points. Now, as Kevin mentioned previously, because the imagery is captured with associated information, Ortho Engine will automatically read it in. This is great because we don't have to import any external EO files or set the projection in this window. What I can do is just click cancel. It says it will input the information from the first available image we ingest, which is great. And we're now going to set the camera calibration. So what we see here is the first processing step called the project. This is where we're going to just set the project. We've created the file. We're then going to set the projection, which we'll do when we ingest all the images, and we're going to set the camera calibration. Just the whole outline of Ortho Engine is a series of processing steps through sequential order, and depending upon what data you're working with and what you're trying to derive, you may use some or all of the steps. So I'm just going to go import for the camera calibration, and I'm going to point to a camera calibration located here. Just going to quickly open up the XML file so we can just see what it looks like in Notepad. For instance, we just have all the associated information, focal length, any distortions, and I'm just going to go to this XML file, which is from a third-party source, an external source, and just click OK, and now the camera calibration has been set. Now, I'm going to go to the next processing step, which is called data input, because we're going to input all of our data. So we're going to select the Open Images window icon on the far left and select the Add Images. Here, we're going to go to our JPEG files and click and select all of them. I'm only doing a little subset just for this for speed for this process, but we're not going to actually convert them into PIX file, even though it does optimize processing. We don't need it for this process. I'm going to click No. It's going to ingest them. Wonderful. 18 have been loaded, and they've been listed here. I'm just going to close this. And because we have the EXIF tags, I can just quickly open up the EO file orientation data, and we can see the XYZ, omega phi kappas have already been set. We can then view, because we have all this information, we can actually view in a project overview the estimated footprints of all of the images. So we can see them all displayed here. I can actually right click on the image tree, just go to Show, Imagery, and we can see an estimated display of all the images. These images have not been improved with their initial triangulation, but we're going to do that now. So for the next processing step is GCP and TP collection. This is where we improve the AT of the project, the triangulation or the model. Here we can collect ground control points and tie points either manually or automatically. And for this instance, we're just going to collect tie points. So I'm going to select the automatically collect tie point, and we're going to utilize that new method that Kevin mentioned called FBM. Here, I want to bring attention to two of the parameters we see available. One is the rejection threshold, which is just a value in pixels by which the system will eliminate any blundering points when it's collecting the tie points. And then the thinning points, as Kevin mentioned, thousands of points can be collected, and this is just to help thin them out for your model, for your end model, so you can process. So we're going to leave these at automatic, and then we can just click the collect tie points, and then we'll have our tie points collected. But of course, for the interest of this webinar and for time, I've actually gone ahead and done that. So I'm going to close this. I'm going to just save the webinar project file and close it. And we're going to take up the next project file, TP collection, pretty much right from where we just left off. We can see I've collected high points. I can view the residual port, which is just a report that documents the overall block model of residual error of the block and of the individual points associated. I'm just going to compute the model to see the overall error in this project based upon the tie points we just collected, and I haven't done any refinement. This is all fresh. So we can see the overall residual of the block is around 2.6 to 1.6 in the X and Y, and we have a number of of points that have a high RMS, high blundering. So these are problematic points that are bringing up the overall residual error of this project. So we can either manually remove them, or we can utilize that new tool that Kevin mentioned, the automatic point thinning and refinement. Here we have a number of different options, and I'm just going to take your attention to a few. We're not going to thin points. We're just going to leave the refine point option. We're going to select tie points because we only have tie points. We're going to utilize the progressive refinement method, which will refine the block through an iterative step process. I'm then going to select the maximum residual of the overall project to be actually 1 pixel RMS. If I had a large block of images, I could deactivate any images that actually don't collect or don't have any or have insufficient number of tie points that could be causing problems for the model. But I'm going to leave that at default. I'm just going to run it. It's going to take just a few seconds, so please bear with me. But what we can see is it's going through the iterative step right now in the window. So it's removing tie points, bringing more tie points back in to just try and achieve that overall residual error. And of course, as we're going through this process, please put some questions in the questions panel if you have any. Kevin is there to answer them, or we'll answer them at the Q&A. And hey, here we go, it's all done. What we can see here is 18 images were processed, initial is 679, and of tie points that were collected and then refined to 667. So now, if we remember, the initial residual error was 2.6 and 1.6. With this improvement, we now have an overall residual error of less than 1 pixel. We have around 0.36. So I'm going to accept the changes. I'm going to close the residual port, and I'm going to open up the residual port and close the refinement panel. And what we can see here is the tie points have been refined. The highest residual is 1.33, but the block is improved. We can even view the project overview and see that the footprints have changed. We can show the images, so there is better alignment between all of them. And to check the distribution of tie points, I'm going to go select tie points. And we can see there's a good distribution in the center of this block. And we can even view the summary table to see that the lowest number of tie points that were collected for each of the images is 88. So we have a good distribution and a good number. So now, once we've collected tie points and improved the AT, we can then generate a DEM. Now, for the generating of the DEM, it's a two-step process. We're going to select the DEM from stereo overlap because that's what we have. And it's a two-step process in way that we create epipolar pairs between the stereo images, and then we generate the DEM between the pairs, geocode them, and then merge them together. So that's a two-step process, but for the interest of time, of course, I've already gone ahead and done that. So we're going to close this project. I'm going to discard the changes we made because the next project has that. So I'm going to select the DEM from stereo and create epipolar pairs. Here we can automatically identify the pairs in the project, generate them, as we see with the generate, and these pairs can then be the elevation models from each of the pairs can then be extracted. So here we have all the pairs in the project. We can use the SGM matching method. We can collect one-to-one resolution DSM by choosing the pixel sampling interval as 1. So we're going to utilize every single pixel for the DEM, and that automatically identifies that we can extract a DSM at 9 centimeter resolution. We can then select the geocode DEM, point to an output, let's go here. I'm going to just type in DEM. We can save it. Give it a few seconds. Wonderful. And then go 0.09. Lovely. So now we're going to generate a 9 centimeter resolution DEM. However, one of the new features that Kevin mentioned is that merge option, and we're going to choose that in the output options at the below right here where it says blending. We're just going to select blending and choose merge. Wonderful. And now we can extract the DEM to be used for our orthorectification. Of course, that's going to take a bit too much time, but I already have the results available. So I'm going to just showcase what the DEM looks like. So here we see the raw images we've just collected, and this is the DEM that we can extract from that process. I've done a little bit of editing, but we're going to actually go into more detail about that later on. So here's the DEM. I'm going to close that. We can then go to the next processing step called Ortho Generation. Here in the Ortho step, we can set the ortho rectification. What we see is we have the available images in our project. We can then select them or move all of them to the table for images to process. We can choose an output location. We can browse to a specific output location. We can set the DEM file, so the DEM we've generated, and I'm going to point to my DSM. Click OK. Wonderful. And an important note is we mentioned true orthos or DSM ortho imagery. We can then, to do that, we have to select the apply true ortho rectification. Now it's very important. We can generate these true ortho images because we have the sufficient amount of overlap. We've generated an elevation model or DSM at the same resolution of the images. So we need to have a certain number of parameters set for us to actually generate these products. Now it's important to note that based upon the DEM you're using, this process a number of voids could occur if there's errors in the DEM, which we'll actually see a few of them, especially in the forested area just because of elevation values. And another note is in a more urban setting, it's suggested that after you generate these true ortho images, for instance, buildings can have sharp edges or jagged edges potentially based on the DEM, based on errors or blunders or artifacts in it. So the best bet, the best suggestion is actually to run another tool, which is called Edge Blur, which you can easily find in our algorithm librarian. You can either run it manually or you can create a Python code to just cycle through all of your ortho images to just blur the edges along buildings just to make a nice, more seamless product. So I've already gone and generated the orthos and I'll show them. So I'm just going to click close. But we can open up and see that once we have the DSM, we can generate all the orthos. And we have a number of artifacts here, but we can easily rectify those in the mosaic step. So here we have all the orthos, some nice alignment, so that's looking good. Again, this is just a little subset of the project the larger project that we downloaded from SenseFly. So once we've generated the orthos, well, we can then mosaic them. And that's a really quick process. We go to the next processing step called mosaic. Here, we just select the mosaicing icon. I have stale orthos. It's asking, do I want to make more? And I don't want to because that's going to take too much time. So I'm just going to click save. Wonderful. And that's going to quickly open up the mosaic tool. And we have a lot of documentation about this whole workflow. So I'm only going to talk about a few points about this. And we have a number of YouTube webinars and YouTube videos about this. But just so we know, the system automatically populates the file list of all the ortho images generated. We can then select an output file. I'm going to just quickly go and select Mosaic, create one called Mosaic Webinar. Why not? I can then set projection, change the resolution to whatever I require. But the next parameter is the cut lines. And so this is quite important because we have such a huge amount of overlap and quite a lot of images in this project or in other UAV data sets, for instance, we can actually constrain the mosaic cut line generation. This is important because this will actually ensure that the most nadir pixels are actually used in the cut line generation. If we have sufficient amount of overlap, then we're going to be able to extract the mosaic with the most nadir pixels. Of course, if you don't, so in this little project, I have 18 images. There might be a few holes in the area, but that's okay. So what we can then do is we'll keep everything at default. We can apply color balancing utilizing the bundle method that Kevin quickly mentioned with dodging points. If we have imagery that have maybe some bright spots, we have hotspot normalization or an adaptive filter as well, but we don't need those for now. I'm just going to click finish. And this is going to take just a few moments. So thank you for your patience. So it's quickly loading them, generating the cut lines, applying color balancing. So a lot of the work that is already done when we're going to get it. We're just going to do a bit of QA. So there we go. It's all done. We have these artifacts that we can easily rectify, but I want to take your attention to two things we can do now. We could edit cut lines. So we see all the cut lines here of each of the images. We can select an image and change this cut line utilizing the reshape tool. Just an example here, I'm just changing the cut line just to help make things more seamless to edit one of the editing capabilities. And then next is color balancing. So I'm just going to go select, where is it? There we go. So I'm going to turn off the cut line visibility, and we can see that in some regions, right here, there's a bit of miscoloration. The color balancing wasn't perfect in that spot. However, we can fix that by using the dodging points. So I'm quickly going to showcase using the dodging points. I'm going to add some dodging points that use current adjustment. So it's just going to act as a barrier so that when I utilize the auto matching between both sides, I can then make a nice seamless image. So that's just one really quick example of how to use the Mosaic tool, and then we can easily select source images, click add to Mosaic, and generate our final Mosaic. I'm just going to quickly close this. I'm not going to save it, just so we can see that the final Mosaic after some editing is something like this. Now, Kevin did mention a number of editing tools. So we have the DSM Editor and we have the Smart Geofill. And I want to quickly cover those two tools. Here, this is the full data set of our quarry. And here I'm going to utilize the DSM editing tool, Live Ortho Preview. I'm just going to briefly go over it just in the interest of time. But we can see here is in this little area that the DSM extracted, we have a number of artifacts over this, this feature. We can then select the layer tab, go to the DSM editing. We can display the grayscale image. And what we see is there's a number of artifacts over this feature. We can then utilize our Live Ortho Preview tool, which will actually cycle through all the orthos linked to this DEM, and on the fly ortho rectify them based upon the DEM values we have available. So we can see here these ortho pixels. Now, I want to create two editing polygons to just fix these artifacts. So I'm just going to click the vector polygon layer. I'm going to create the polygon. I'm going to create two of them. First, I'm going to just briefly create one along the edge. I can even turn the DEM off and just make sure I get a nice edge around it, this feature. Wonderful. Making sure. One, two, three. Wonderful. So now I'm just going to quickly, there we go. And what we can see here is immediately the polygon of the vector I created is displayed in the Live Ortho Preview. And I can cycle through all the overlapping images. And we can, just to help visualize. And I'm going to create one more polygon just around the area of interest as well. Thank you for everyone's patience. I will be done in just a second. I just want to showcase this. Excellent. Okay, so we see two polygons. So my first edit I'm going to do here is the, just going to change that. There we go. is I'm going to fill from vertices. I'm going to clean up all the artifacts around the area. So I'm going to choose the fill from vertices and blend width of 10. And I'm going to apply it. And pay attention as well to the area around that I've created. And I'm going to click apply. And we can see immediately that there's been a change. I have to cycle through. So if I go back, Control Z, we can see that there's been a change immediately. Then if I selected the other polygon, this one, and I'm going to choose the opposite ends fill, blend ends only. I'm just going to choose another blend width of 10. I'm going to click the apply with overwrite. So it's going to make a nice clean polygon, and we can see dynamically it's been changed. We can of course edit this, but for the interest of this webinar, I won't go too much more into depth on this. We have a lot of documentation and material on this, but I just want everyone to be aware that we have this live ortho preview option, so you can easily identify your orthos before actually generating them, and based upon the DEM you're working with, so you can actually QA it, see what happens, see the effects it has on your orthos, and you can easily fix that and go back. Just because instead of having to create your orthos, identify areas of issue, go back to them into the DEM, fix the DEM, and regenerate the orthos. This just saves you a lot of time. So I'm actually going to close the live ortho preview. I'm going to close this. I'm not going to save it. And I'm going to go to the next tool. Here we see the a final mosaic I have of the area. And I utilize the true ortho rectification capabilities. So we can see there's a few artifacts, and there are quite a few as well along the edges, but that's just due to the lack of overlap in that area. But we can see here at that that elevator or feature that there's some artifacts just along it. But we can fix these and we can clean these up utilizing the Smart Geofill. So this is a mosaic, and potentially I missed that during my mosaic editing, my mosaic stage. But I can, instead of going back to the mosaic tool, I can go to Tools, to the Smart Geofill, which enables me to select, I'll select Open, and to select all of the orthos that I've already generated and utilize their pixels in this mosaic. So we can see is when I create an area of interest around this artifact, or these artifacts, I'm just going to go around this whole building, and we can see a few of those voids that I mentioned based upon the DEM present. So I'm going to create that area, delineate it, and we can see that it automatically will identify, of all the images we loaded, which ones are overlapping that area. And then we can, as we can see here, I'm just going to zoom out a little bit, we can cycle through to figure out what is the best bet, what is the best image that contains the best pixels. We can also select the blend with just to make a nice so a nice seamless blending, but also perform some automatic color balancing, so we don't have to worry about going back to the mosaic tool and doing any of that editing. So I'm just going to zoom in a little bit and just cycle through the options. And here we have 1 for 9, for instance. I'm going to choose a few more. 1 second. Okay. This removes those artifacts. So I'm gonna select these pixels right here, and the way we go about pasting them in is simply the paste icon. So I can click paste. I can then turn off this delineated area, and we can see that those pixels have now been pasted into the mosaic. I can save this mosaic and then use this area, so I don't have to go back to my mosaic step and redo any of those edits. I can just do it right here in front of me. So these are just 2. So we've gone through the whole UAV workflow. I've then showcased a number of editing tools we have available, but there's one more thing I'd like to talk about, and that is some application. So I'm just going to quickly go back to the PowerPoint. And
sorry,
before
Jason,
that, just to Kevin's going to step in.
Yeah, just want to give you a little break and have a chance to drink some more water. So I'll take over talking just for a couple of minutes here. So just really quickly, now that you've seen kind of this this workflow, we're just wondering, one of the things that we didn't really talk about so far is the different environments that we can deploy this technology to. So far, what we've been showing you is our desktop tool. That's obviously a nice way to demonstrate in the context of a webinar. But all of this technology, as I mentioned, is Python enabled. So you could develop a script and you could deploy a workflow on a desktop machine, or you could actually deploy that to the cloud. So we could turn that whole workflow into a cloud-based software as a service application. There's other options as well. So I'm not sure if you prefer to OEM this like right into your processing platform, like you actually want to white label or take our technology and embed it within your platform. Maybe that's an option. Or if you're doing something else different than what you see here, we'd be happy to hear about what's your preferred environment for processing UAV imagery. I don't want to bias the poll, but I have several colleagues and friends from the industry who fly UAVs, and I guess because of the nature of the work, you're in the field. Typically, you need to deliver data really quickly, so desktop is often used. So a series of laptops are kind of brought to the field, SD cards are pulled out, and that tends to be the way people work, but it doesn't have to be the way, depending on timelines, I guess. So I'm going to close that down in 3 seconds. So 1, 2, 3, and I want to thank you for your response. And as suspected, quite a few of you prefer to use a desktop environment, but there's a few of you out there who are looking to do things a little bit differently. So thanks for the input on that. And I'm just going to go to the next slide and introduce it for you, Jason, so you have a little bit more time to catch your breath. So if I can get the next slide. So what Jason's going to talk about right now is how you can actually use some of this additional functionality that we talked about. So we of course have this full workflow that we've developed that's suitable for UAV because of all of the work that we've done on satellite photogrammetry and aerial photogrammetry. But you can leverage all of these 550 plus algorithms available within Geomatica, one of which we are choosing to highlight here is Object Analyst. So we have this tool that allows you to extract features from imagery, and Jason's going to give you a demo that basically seeks to extract volume from stockpiles in a particular mining site. So what he'll do is he'll use the DSM that's been extracted from the elevation data, from the stereo data and the UAV data set. So we've extracted the DSM at 1:1 resolution, and then he's going to leverage the DTM, which we've filtered. So we have the DSM and the DTM. So we have a normalized height model. And then he's going to extract the actual volume in cubic meters using the formula that you see there on the bottom of the screen. So the pixel resolution squared times the sum of the height of the pixels. So I'm going to pass it back to Jason, and hopefully we can get through this demo quickly. We're running short on time, but here we go. Oh, you're muted, Jason. We can't hear you. So
thanks, Kevin. Just finished the last cup, so on to the next one. Hello, everyone, again. So as Kevin mentioned, I'm going to quickly go over another application for volumetric analysis. So what we found is that working with this data set, there was a number of different stockpiles, and dealing with UAV imagery in these areas, that could be something people are very interested in extracting and delineating. So there's a number of different ways in the Geomatica environment we can actually extract that information, but I wanted to utilize Object Analyst for a number of reasons. One is in certain areas, manually digitizing piles to then use for the extraction may not be time efficient, or it may be very difficult, because if you have areas around like these piles of tires, it could be a little difficult to get a nice delineated area. Also, if you're working with large data sets, you may need to actually introduce some automation. And so the Object Analyst with BAV actually introduces a number of automated procedures to help streamline your processing. So I'm going to quickly go over this whole process. For those of you who are who have attended the past Object Analyst webinars, this will be very familiar to you. It's great to have you back. So I just want to quickly go over the object-based process, and it is a multi-step tool in the Object Analyst where we segment the imagery based upon similar pixels or objects based upon the scale and the shape and its compactness. We then can extract associated attributes from the underlying pixel values of our imagery, and then collect training sites for supervised classification, and then run the classification. And at this classification step here, I'm going to just click edit, we can save a training model. And this training model will then be utilized for repeatability for other imagery to classify all the segments that we can extract from the other image data sets. So once you do it on one template image, you can easily do it for your whole other data set. So if you have, because UAV has a high temporal resolution, if you collect it on one data set, then regularly when you collect other image data sets of the DEM and the ortho mosaics, you can then utilize the same training model for that. So just to quickly go over my workflow, I wanted to identify in an area of interest the volume in cubic meters. So most of the data you're going to see is very familiar. I have the mosaic, I have the digital service model, I have the slope, not the slop, that was seen in that little PowerPoint. And I'm going to utilize these three data sets to perform my segmentation of the image. So I delineated a little area of interest in this mosaic, and I actually clipped it out because before we could see a larger area of interest or a larger mosaic. I then delineated the area. I then ran the segmentation, and I had my segmentation parameters to be scale of 35 with a shape of 0.9 and a compactness of 0.8, just to make sure that we really delineate certain piles. For instance, here, we're getting segments that are properly following the tire pile and are not going over into the other features in this image. So this was very important for me because I only wanted to extract information for these segments from the piles themselves. So once I collected the segments, I could then extract attributes. So I collected the mean and standard deviation of the red, green, and blue, the DSM, and the slope. I collected additional geometrical attributes and one vegetation index, which was GI or greenness index, just to help identify what is vegetation, what's not, because I needed to make sure I collected a wide array of different training sites. And then lastly, texture for mean and standard deviation. So once I collected that, it was associated to the attribute table, and I could then run and collect a number of training sites. Here, I collected what's a building, what is just a ground, what is vegetated, and then what are my piles. And what we could see is I'm actually going to take my image here. I wanted to make sure I get these piles of interest, this one, and these three, just to make sure I have a good distribution. And with this training model, these training sites, I can then perform the final classification. And here's just the result of the full classification. I'm going to then turn off the buildings, the ground, and the vegetation. And we could see that there's some misclassification, but that can be easily rectified with a rule-based classification. But for now, we just see the nice piles have been delineated. So I can then dissolve them all together to create and identify the piles that I'm interested in. So we have the piles here that I extracted. I could then run the DSM to DTM filtering. So I filtered out these piles from the DTM. So then I can generate a change detection, a height model actually, utilizing our analysis change detection tool. So selecting the working raster to be the DSM and the reference to be the DTM, setting an inclusion mask with these piles, and utilizing that to then extract the height of each of the piles. I could then perform the sum or generate the analysis of the sum to get all the pixel values of each of the segments. So I'm just going to open up the attribute piles here. And with the sum, I then perform that whole calculation that Kevin showcased in the slide to get the volume of in meters cubed. So we now have a workflow that we can utilize to extract volumes, and this can easily be done with repeatability and with confidence with the Object Analyst tool. And we have a lot more documentation and information if you're very curious on how to leverage this tool for your purpose.
Great, thanks, Jason. I'm gonna keep things moving here. So just gonna do another quick poll. So while we got everybody here, still thanks for sticking around. So we just have a quick question about if you could improve one thing in your UAV workflow, what would it be? Are you concerned about reducing processing and editing times? Are you looking to implement a scalable UAV processing solution? Do you want to improve the quality of your results? So there's no right or wrong answer. It's just which ones are you mostly interested in? You can tick as many as you like. Are you looking to automatically extract features from UAV imagery, or is there something else that you're trying to do that we haven't thought of on this poll? We'd love to hear about it. So, you know, we do these interactive polls to try to understand what you, our customers, existing and prospective, are trying to do, and that helps shape what we do with our technology and what direction we go in. So a great opportunity to give us feedback and shape the way we develop our software. So I'm going to leave that open for just a few more seconds. We're running short on time, so 3, 2, 1. Thank you so much. Just quickly share the results there. So looks like a nice distribution, primarily looking at the quality of the results seems to be the most important one, followed by processing times and then extracting features from imagery or vice versa. So thank you for that. Just moving along to try to sum up. So we've introduced our new UAV technology. We've talked about our processing all the way through. And we have, I'm not going to go through all this again. I think we've talked about it. I'm just going to jump to the resources, Jason, if you can get to the next slide. So we really encourage you to head to our support website. So we have support.pcigeomatics.com as a destination where you can go to get help. We have our community forum, which is what's up on the screen right now. So you can post a question, you can get help from other Geomatica users or PCI staff. A number of the staff here at PCI are notified as soon as an email hits that forum, and we'll jump in and help if required. We have our YouTube channels. We have a number of playlists and dedicated topics as relating to Object Analyst and photogrammetry and so on. And we have a specific workflow tutorial that was just published recently. It looks like it was published, I think it was 2 weeks ago, maybe a little bit more. And that's basically running all the way through the whole workflow as per Jason's quick demo. So you could definitely go back and rewatch this webinar to understand the steps, or if you're more of a the type of learner that needs to see all the steps written down and follow them one by one, we supply you with a data set which we use, which is openly available. It's a SenseFly data set, and you can download it and basically run through the whole workflow just like Jason did, except with the whole data set, not just a small subset. So again, more webinars coming. Sentinel One Top's radar topic coming up next week, and then another radar topic coming up in February. We're going to go to Q&A at this point, and let's see if there were specific questions. Jason, help me out if you see any, and if you want to jump and address any specific questions that have come up. Just trying to get the questions panel up. So we had a question about using the trial version, so whether UAV processing can be done with the Geomatica trial version. And absolutely, that is possible. So you can go to getgeomatica.com. You can fill out the form. You can download a 30-day trial of the software. It's a fully functioning 30-day trial. You will get a warning of how many days are left as you're working with the software, but you can produce outputs. And if you want more time, then we encourage you to get in touch with us and you know, let's have a conversation about what you're trying to do, and then we can give you a more resources, more time, whatever it is that you need to evaluate our technology. One of the key things that I didn't mention is we do have a number of staff here at PCI, including our customer support team, but also primarily our technical support specialists, people like Jason, who can actually take delivery of your sample data, run it through a workflow, explain to you the steps that were used, and then show you the results and jump on a call and discuss the quality, the throughput, all that kind of stuff to help you make your decision faster if you're looking to evaluate our technology. So you can either invest the time yourself or have somebody help you to do that, and we're happy to do that. So let's see. We have a question about DTM. Can Geomatica produce a good result for DTM for UAV DSM? So we didn't show too many examples, or we didn't walk you through the whole process. Again, our technology is very advanced, and there's a lot of different capability. We tried to package it, but basically we have automatic DSM to DTM conversion algorithms with a number of terrain filters that are meant to address all of the different situations. So if you're trying to produce a DTM, typically you want to remove vegetation, you want to remove buildings, but you want to preserve the natural terrain, things like specific slopes or specific cliffs or things like that. So you can leverage our automatic methods, and you can also use our advanced DEM editing tools to do things like put break lines in or do manual edits in specific areas where the terrain's a little bit more challenging. So we really give you a good balance of automated and manual tools, and we've got lots of topics or lots of YouTube webinars on editing DSMs to produce DTMs. Just trying to see what else there is. Those are most of the questions, and we've kind of gone into overtime. We're 6 minutes in overtime. At this point, I would like to thank you all for making the time to evaluate and think about PCI technology, and thank Jason for his demo, and wish you all the best. Just forgot to turn my camera back on there. So, so from all of us here at PCI Geomatics, thanks for tuning in. And we'll see you on the next webinar next Tuesday at 8 a.m. once again. So take care, everyone. Have a good day.